a warm welcome to the Nobel Prize Museum in Stockholm, Sweden, planet Earth. You are more than welcome here today when we are calling space. How cool is that? Yeah, I'm going to get this boost. So, together with the European Space Agency, we will soon connect to the International Space Station and talk to the astronaut Jessica Meir and Luca Parmitano. And today is a very special day for us who work with the Nobel Prize, because it's the beginning of the Nobel Week 2019. And this morning, we had the great privilege to welcome class of 2019, all the laureates for this year, here at the museum, actually their own museum. And this museum is a museum about ideas that changed the world. And the people we are having here on stage today truly has changed the world and how we look at it. My name is Anna Sjöström-Douagy, and I'm the Science and Program Director of the Nobel Prize Programs. And I have this great privilege to introduce our guests today. So we have two physics laureates, Didier Queloz, Michel, and one chemistry laureate, Stanley Whittingham. Please, a great welcome. And congratulations to your Nobel Prizes.
Thank you.
Every year, as new Nobel Prizes are announced, new ideas are added to our museum. And these ideas are your personal stories, are what we talk about and when we use the Nobel Prize to inspire the world. And all of you you will hang up here in the roof, and then we will sit on you in the bistro eventually. So it's everything from high to low here. And I know that all of you have been donating objects to the museum today, and which helps us to talk about your discoveries and about your personal work. So, of course, I need to take this opportunity to ask what you donated and how that's connected to your discoveries that was awarded with the Nobel Prize. So I start with you, Didier. And the microphone is here.
Yeah, thank you. Oh, is it on? It's on, okay, right. The discovery we made 25 years ago, we did it using a telescope that is located in south of France in an observatory called Observatoire de Haute-Provence. We can visit the site there, and I happen to spend a lot of time in this place to build the instrument and then to operate the instruments. So I was so much in my home there that I got something that was very dear to me, and I decided to donate to this museum. And what I donated is the key of the telescope.
Wow.
That I use every time to go there. So this museum has now the key of the 193 centimeter telescope, where we had LOD, the spectrograph. That was the tool we used to discover the planet orbiting 51 Peg.
We have the keys to the exoplanets. And Michel, now, what did you donate today?
Yes, something like 40 years ago, I started the same observatory, building and developing new techniques to measure precisely the velocity of stars. And the heart of this technique, the spectrograph, is a small piece of glass coated with chromium with several thousand of small holes inside, just to do what is called the cross-correlation technique. So to try to extract the velocity of the star just from thousands of atomic lines in the spectrum. So this special piece is here in the museum.
Detecting the stars.
Yes. And then after, 20 years later, we have developed the new spectrograph, LOD, based on the same principle and having allowed the detection of the first planet.
Wow. Now you see why you have to come and visit us here at the museum. And Stan, what did you donate today?
Well, I think most of you know I've been working on lithium batteries for about 50 years. So we started at Exxon, we built some batteries in the early 1970s, and we were able to find 2 of the original batteries from the 1970s, and they're now in the museum together with a brochure.
Wow. And it's amazing that it's so many years ago that you started, and we are now in this phase. So right now, in the International Space Station, your discoveries are crucial for their work, and cosmology and exoplanets are the key themes that are investigated by the ESA. And Didier and Michel, you have been awarded for the discovery of the first exoplanet. Can you very briefly say why it's important with exoplanets or the discovery of that?
Well, the discovery of the first planet orbiting another star was really one step further in the understanding where we sit. It took some time to understand that the Earth is orbiting around the Sun. It took some time that there is, billions and billions of stars in galaxies, and the universe was big. And what we did, it was just detected the first of planet orbiting another star, so expanding a bit the horizon and trying to understand how rare we are, and do they have many Earth around other stars? We still don't know everything, but just we open this window to all these many planetary systems that exist, and we have now thousands of planets that we've detected. It's pretty obvious there is a lot of planets orbiting other stars.
And Michel, do you think that this discovery, now we say that we have maybe many more like the planet Earth out there, is it increasing that we find life in space? Or?
Yes, we have 200 billion of stars in the Milky Way. Right now, with the new discoveries, we know that almost all stars have planetary systems. Some of them could have rocky planets at a good distance for the chemistry of life. So, but if it's only 100 or 1/1000, is still a huge number of possibilities. So we are sure that we have a lot of rocky planets with good conditions for life development. Now, for the next generation, this is a big goal, is a good challenge to try to find if we can find some evidence of life.
Good day at work, I would say.
No, but it's very good for young people.
Yes. Yeah, there's a lot of things to do.
Yes.
So go to science, please. So Stan, right now at the space station, I learned that they are actually changing batteries. So lithium-ion batteries that you were awarded for are actually used in space. So why it's so good with lithium-ion batteries?
Well, lithium-ion batteries store much more energy per weight or per volume. So they're ideal for space. They're very happy in that kind of environment. So I think the Moon rover and the Mars rover have been using lithium-ion batteries for a while. And now they're being put into the space station. I think everyone's comfortable with them. And I was going to ask, is there anybody in this audience who hasn't got a lithium-ion battery on them now?
But were you sure that they would function in space, so that you knew that they worked up there as well?
So they've been used on the Moon rover and the Mars rover quite satisfactorily. So they work well with solar cells.
That's great. So did any one of you dreamed of being an astronaut when you were young?
No. Yes.
Yeah! Because I noticed that some of you are quite happy when you met the person that we will now invite up on stage, because we are so happy that right now in space up there your work is being implemented, and we are now soon going to have a live call with Jessica Meir and Luca Parmitano. And who would be better to connect us to space than our own Swedish astronaut, Christer Fuglesang. Please welcome on stage. A warm welcome.
Så mycket folk.
And I must ask you, how does it feel for you now to be with us here on Earth and not with your colleagues in space?
That's a hard call, actually. It's amazing to be with Nobel Laureates, but it's also amazing to be up there floating around. So Yeah.
So you have been there, and you have been on the side where you are waiting for in live call to happen. So what is happening there right now?
So they are preparing the cameras. They probably kind of make sure that all the radio connections are okay. They're doing it from the Japanese laboratory called Kibu. There's several laboratories up there. There's also a European one called Columbus. But the live calls are normally made from there. Here they are actually in the airlock, where two of them are going prepared to go out on a spacewalk. But there's the two one in the blue shirts there we will talk to, Jessica and Luca.
So I think I will leave you so you take off for space. So I think I leave the floor to you guys now.
Yeah, now it's the most exciting here. We are waiting for Houston to call us, and then they will kind of initiate the connection with the International Space Station. And that is normally done very much precisely on time. So I think we have a few more. We are precisely on time, they say here in my ear. That's great to hear. So, you know, you said you dreamed of being an astronaut. I was dreaming once I could get the Nobel Prize in physics, but I didn't get that. So we are one equal there. Yeah, I know. So, let's see, what can we say more here? 3 minutes out. So, what you see here is, can talk about the amazing spacesuits. You know, one of the problems with these spacesuits is that we have as low pressure as we can, because since it's vacuum outside, but it's still then 1/3 of an atmosphere. So it's really like a balloon. It's very clumsy to work in, but it's pure oxygen. And when you go outside, you risk getting the kind of diving sickness, like when you come from below. So you have to prepare your body a lot. So still have a minute. So maybe, is there any question I could answer while we are waiting for a connection there about what's going on up there? Or one of the things which they have been doing, they're doing a lot of spacewalk recently, partly for changing these batteries, the new better lithium batteries. Another thing is that they are doing repair work on a very sophisticated physics experiment on outside, an astroparticle physics experiment called AMS. We're detecting particles from space and hopefully see maybe some signs what's called dark matter. Dark matter is something we don't know what it is, but we know it's out there because we can see how stars and galaxies move around each other. And Luca, to right there, he will probably go out tomorrow or any of the coming days for his 6th spacewalk. And with that, he will make a new European record in number of spacewalks. I happen to have the current one, 5. But it's time for someone to break that record. So, all right. Still 1 minute out. Oh, now we see the Mission Control Center in Houston. And so the interesting thing with this is that the main people are sitting in the back, actually, and then the further forward you go, well, I wouldn't say they're less important they are, but the flight controller, flight director is there in the back, and then besides him, he has, I think that's probably him, and there is probably the so-called Capcom, normally the only person who's allowed to speak to the space station. But we'll make an exception today. We'll let Nobel Laureates speak to the space station as well. And they are kind of all looking towards the screen over here where they can see where the space station is right now and information on when are the connections, radio connections, and things like that. And wow, look at that. They're already in Christmas time.
Station, this is Houston. Are you ready for the event?
Mr. Station, we're ready for the event.
ESA, this is Mission Control Houston. Please call the station for a voice check.
Station, this is Christer Fuglesang. How do you read me?
Men hejsan, Christer. We read you loud and clear.
Hej Jessica, härligt att höra dig prata svenska. Hello Luca also. We are here at the Nobel Prize Museum in Stockholm with 3 Nobel Laureates who are very eager to ask you some questions and talk to you. And they will each ask one question each for each of you. And then if you don't answer too long, I hope you will also have some questions for them. So let me start by giving the mic to Didier.
It's an amazing moment. Ooh. Luca, from the International Space Stations, you should enjoy a view on our own planet that many of us would love to see in their own eyes. We can only dream to obtain similar perspective on old planet that we have detected on other stars. How much do you think the Earth view from space is inspiring to look for exoplanets?
I can only express my own personal opinion and feelings when I talk about the view from up here when I look at the Earth. On the hours and the days before coming back to ground last time on Expedition 36 and 37, I remember having this very distinct thought come to my head that even though I had been looking and admiring the curves and the colors and the liveliness of Earth, I was very lucky because that was my planet and that's home. And if I had been an alien coming from I don't know where, from an incredible voyage, looking down at our planet, I would have desired nothing else than just land and enjoy the sights from up close. So I think that, yes, it does inspire us because our planet is beautiful and amazing, and it's our only planet right now. And if we could find signs of planets that are similar to our Earth, it would be an amazing discovery. And I think that we are heading in the right direction. Our technology and our science helps us both imagine but also getting closer to those planets. And so I think that our views of our own planets from up here are a very strong inspiration.
Jessica. So Jessica, I have a question for you. It's amazing. As a marine biologist and physiologist, I would be really curious to hear your thoughts about the prospect to detect life on exoplanet and what kind of life forms you would envision personally.
People like this.
Yeah, as astronauts, we get asked about other forms of life frequently during interviews, and I think we would be very naive to think statistically that there is no life on other planets. And of course, that's why there is so much effort in looking for life. One of the interesting things to think about is, of course, that life might not look anything like us. It might be entirely different. It might not even be carbon-based. It could be based on an entirely different combination of molecules. And it may be something that we don't expect at all. Going back to that background in marine biology, it reminds me of when hydrothermal vents were discovered in the deep ocean crevices back in the 70s. In the late 70s, actually, I think it was the year that I was born or the year before, that researchers from my very own graduate school, from Scripps Institution of Oceanography, discovered those first hydrothermal vents. And until that time, people had this traditional view that life, of course, was always based on harnessing energy from a sun or some kind of equivalent star. The photosynthesis, which of course we learn about in grade school. With these hydrothermal vents, we saw for the first time these thriving ecosystems that were based entirely on chemosynthesis. So the chemosynthetic bacteria were fueling this. There was no light getting down to those significant depths. Scientists had thought maybe it's this marine snow that is falling from above that is providing all the nutrients, but it wasn't that. It was actually the chemosynthetic bacteria that were supporting themselves from the sulfur in these hydrothermal vents, supporting that amazing ecosystem. So I think that's a really interesting analogy to think we may find something completely unexpected that may change our perspective about what life truly is.
Yes. I don't have question on the dynamics of the microphone, but but I have a question to Luca. Please, space science, exploration, research require patience, dedication, and commitment. What are the goals that you have been striving for, and how did you keep your motivation up during your full career? What is your advice to young scientists, young students with a passion for space science and exploration?
Well, I'll answer the second question first because it's the easier answer. I think that the most important thing that I would suggest to anybody that wants to be involved in the future in space, science, technology, exploration is stay curious. Don't ever accept a fact, don't ever accept an answer as a given. Just be curious, question everything. Up here, we really love getting answers and finding answers to questions and finding new technologies, test new experiments. But I think that every time we find an answer, there are 10 more questions that rise up. And I think that that's even more interesting because our curiosity is sparked by those questions. So to anybody at any school level, at any grade level, from kindergartners all the way to grad students and postdoc, stay curious. Our universe has really an infinite amount of questions to be answered. And so by being curious, you will always be inspired to question more, to do more, to strive for the next thing. And as far as I'm concerned, my curiosity has certainly been a driving factor. I'm not a scientist. I'm more of a technician coming from an operational background. But that doesn't mean that I cannot be very curious about what surrounds me. I'm constantly asking questions from people that know a lot more than I do about stuff that I don't know anything about. Physiology, biology, astrophysics, chemistry. Some of my best friends are professors in Italy. One of them is an exoplanetary expert in Turin. Another one is a professor of chemistry in Sicily. And I'm always asking questions, reading books. So that curiosity has always been a driving factor. And then possibly one other thing is just the desire to be contributing somehow. Science, human spaceflight is probably one place where science, technology, and exploration really come together. And if I can give a very small contribution to that path, then I will consider myself satisfied.
Thank you very much. And now I have a much more difficult question for Jessica. In the coming years, we are planning to characterize extrasolar planet, density, internal composition, atmosphere, and so on. How do you see this investigation are related to the scientific experiment you are carrying out, the IC?
Yeah, one of the most exciting things that we do, of course, is the wide array of different scientific experiments up here on the International Space Station, ranging everything from physiology, medicine, chemistry, combustion science, you name it, we're doing it up here. There have been some experiments that have looked at some of these basic gravitational physics principles. One example is a payload that was called Meteor, and it was installed in an observational facility which provides a great view looking down on the Earth. And this was the first time that observations were made of the chemical composition of meteors as they re-entered the Earth's atmosphere using a visual spectrometer. So if we start using some of these examples to look at the properties and the formation of the composition of these meteors, of course that can tell us a lot about how planetary bodies of all kinds formed in our universe. There's another example looking at this basic gravitational physics of a facility called Hermes and a Hermes experiment, which is looking at how planetary bodies might coalesce. So there are actually some direct applications to, maybe it's still a little bit of a stretch to your exoplanet research, but I think it can tell us a lot about the formation of planetary bodies of the solar system and within the universe.
Thank you.
Jessica, Stan Whittingham here. I understand you've recently undertaken spacewalks to replace the old nickel-based batteries with the new lithium-ion batteries on the exterior of the station. How do these batteries compare with those you've been used to in the past?
Well, first of all, for all three of you, it is truly an honor to be speaking with you and these scientific greats like the three of you today. And Dr. Whittingham, we understand that as the founding father of rechargeable lithium-ion batteries, we have you to thank for our significant power upgrades here on the International Space Station. And you're right, we were conducting these spacewalks just a couple months ago. We were upgrading the power channels with these nickel hydrogen batteries that we used in the past with the new lithium-ion batteries. And they have a significant performance advantage over the older batteries. Namely, we are replacing 2 nickel hydrogen batteries with 1 lithium-ion. So a very significant capacity advantage there. And they are actually certified to be used for 10 years instead of the 6.5 years of the previous batteries. Now, I think it's really significant for spaceflight to look at that mass advantage, 1 battery for 2 batteries. Of course, everything that we launch up to space is incredibly expensive and takes a lot of effort to get up here, so that was a big savings for us. So we thank you very much for your contribution to the International Space Station.
So, Luca, following on that, space is an extreme environment. Are there particularly operating restrictions for your lithium-ion batteries in terms of hot and cold and other activities?
I just came back from last Monday. I was out with astronaut Drew Morgan for another extravehicular activity, just like Jessica performed a few weeks ago. And we know from experience that when we are in the shade, it gets really cold really fast. I think that the surface temperature is about minus 150, minus 180 degrees. And when we are in insolation, it's the opposite, about 150, 180. So obviously, it's a very extreme environment. So yeah, the batteries, the new batteries and the old ones, but especially the new ones, the lithium-ion, they need to be somehow thermostabilized. So here in orbit, convection doesn't work because gravity affects convection. Density doesn't have an effect up here. So in order to thermostabilize them, we use solar heating and an ammonia-based cooling system to keep the batteries as thermally stable as possible. And that way, we ensure continuous energy inside the station from the solar array during the day pass and from the batteries during the night pass. There is another thing that is important about the lithium-ion batteries. We have them inside the station in our portable computers. We have computers all over the space station for personal use, for work, and they run on lithium-ion batteries. Now, when they came on board, we found out that there might have been a chances of a thermal runaway. I think that's the expression, where they get so heated that they might become dangerous. So We actually had to swap some of our old carbon dioxide fire extinguisher with water mist based ones, and so now we have about distributed among the station these water mist water extinguisher. Now I hope never to have to use it, and if one day they expire, maybe we might take a shower. That would be a better use for them than trying to extinguish a fire.
Jessica and Luca, amazing to see you, the roaring applause here. And now I invite you. Do you have some question you would like to ask our Nobel laureates?
Well, the first question is similar to what you asked me. I would really like to know what the recent hypotheses are, or what your hypotheses are for what the first sign of life that we could find might look like.
Yeah, I think I was interesting to hear you because you're a biologist, and there is a different perspective from the physics perspective on this question that try to start from maybe some more unique based principles. So right now there is a lot of progress has been done on the chemistry producing the amino acids, for example, and we're trying to bridge the Earth science or the planetary science perspective into the formation of the chemistry, which is going to drive to life. In a way, life is a kind of a chemistry experiment that turns bad because it leads to something that gets out of control. And we're trying to get the piece of the ingredient which is needed, both from the astrophysics perspective, which means what do we need on the planet, or what kind of delivery do you need to make this possible? And then we want to make sure we understand the chemistry that's going to drive. It's a long way, but given the progress that we have made in the last 10 years with the discovery of planet and now the detection of the atmosphere on some of this planet, I think there is a hope with the next generation of space equipment, the James Webb Space Telescopes, and the next generation following this, that we may be facing life discovery in the next 50 years. And there's always hope that there is life on Mars, and we're going on Mars. So let's just maybe wait a bit.
Thank you very much, Didier. We still have a time
We're
for...
both happy to go to Mars.
Yeah, Luca, the question. Yes, one.
Yeah, my question is going to be very short and mundane, but it's for the three scientists and engineers there. It's a very yes or no questions. Many people, they always ask us if being an astronaut was one of our dream, and everybody has a different answer. But today I'm going to flip the question. I suppose that being a Nobel Prize laureate for a scientist, an engineer, is a dream. It's a lifetime achievement. Would you swap place today? Would you want to be an astronaut if it meant that you didn't get your Nobel Prize?
Yes, that's a difficult question to answer, particularly at maybe my age. If I was younger, yes.
I don't know if it's compatible with the barb to be an astronaut.
Yes, I would, because I think nothing prevents an astronaut to get a Nobel Prize.
Well, I'd like to thank you so much on the station, Jessica and Luca, and I'd like to thank Michel and Stan for being here, and I enjoyed this discussion so much. Thank you, ISS. Handing over to Houston.
Tack så mycket, Christer. Hejsan, alla i Sverige.
So now you, we go up there. So I would like to say thank you. Okay, now we.
Roaring laughs here.
A big thank you to Christer, to the laureates, to all of you who are here.
International Space Station.
And to Houston.
Thank you, Houston. Thanks a lot for the help.
All the participants
Thank you.
from ESA, for the ISS crew, will now be resuming operational space-to-ground communications.
Thank you so much to all of you who are here today at the planet Earth with us in Stockholm. Thank you so much of you who are with us online. Don't miss that if you want to listen to more of these wonderful gentlemen here, they have their Nobel lectures on Sunday, December 8th, at the Aula Magna at Stockholm University. And there is a free entrance here at the December 10 on the Nobel Prize Museum with lovely Nobel lunch and a big talk about the Nobel flowers. And if you don't want to miss everything that is happening during the Nobel Week this year, you go to our webpage at nobelprizemuseum.se. So we really hope that you will have a lovely Nobel Week, and we hope to see you very, very soon again. Big thank you to all of you. Thank you. Thank you so much. Thank you so much. Thank you so much. So,